In this video, we're going to learn how to identify medians in triangles. First of all, there are some straightforward vocabulary. Median of a triangle, if you look at the diagram to the left, the median is a segment. So a segment, remember, is a line, right? So a median is a segment from the vertex to the midpoint of the opposite side. So in other words, if I take the vertex C to the opposite side midpoint, that would be E. So the segment CE is the median. And by the same definition, B is a vertex and F is the midpoint of AC, which is opposite of B. And the third one is A is the vertex and D is the median. So AD, the segment, is the median of the triangle. And obviously, for triangles, there are three medians right here. And notice that there is another point here, P, that's really interesting. That's when all the three medians meet, and they meet at one point, and that one point is called centroid. So here's a theorem here: intersection of medians of a triangle. In other words, what is interesting about this centroid P here? Oops, sorry. What is interesting about this centroid P here? If you look at its location, you notice that P is about 2/3 way on all three medians from the vertex. In other words, look at BP is 2/3 of BF, and AP is 2/3 of AD, and CP is 2/3 of AE. So that's our intersection of medians of a triangle theorem. Let's look at an example here. The triangle STR, we have to draw a median from S to its opposite side. So S is right here. Whoops, sorry. S is right here. And then the median to the opposite side, if you use your rulers and measure the length of TR and cut it in half, that will be our median right there. So so to fill this out, so the side opposite is TR, and then we have to find the midpoint M of TR, and label it. Oh, it's asking us to label it as P. That's all right. We can do P here rather than M. Then we're just going to connect S and P. S&P, that's actually the name of a rating agency. SP is the median of STR, okay? Second example, use centroid. Remember, centroid is, in our previous example, is P, is where all the three medians meet. So use centroid of a triangle. In this diagram, E is the centroid of ABC, and DA is where? DA is the whole thing, is the median, is 27. Find EA and DE. So this is pretty straightforward. If we recall theorem of 4.9, you remember EA has to be 2/3 of the whole length of the median, which is AD or DA, right? Which is right here. And we said DA is 27, so if you do your math, you should end up having 18. Now, if you use the segment addition postulate to find DE, you know that DA equals DE plus AE, or EA. And then DA we know is 27. We don't know DE, we know EA is 18. So our conclusion is DE is 9. And that's because we did our algebra by subtracting 18 on both sides. So EA has a length of 18 and DE has a length of 9. Okay, so it's very straightforward. The centroid P, it's 2/3 of the way from the vertex that we have in the triangle. I think this is the last example. This one says P is the centroid of triangle QRS, and RP is 10. Find RT. Find RT. Okay, so because it's given that it's centroid, so we know all these three lines that meets at P is the median of the triangle. In other words, then we can draw the conclusion that T is the midpoint. So that's all the information we can gather there. So if we use theorem 4.9, we should have this conclusion here that RP is 2/3 of RT, which is the median. And if we do the substitution, RP is 10, we can come up with the conclusion that RT is 15, isn't it 30? Yep, 15. It's because we multiply each sides by the reciprocal of 2/3, which is 3/2. So that's our answer right there, 15. Okay, so there's some checkpoint problem for you to complete. Make sure that you do this. It's fairly straightforward, but it's very useful. All right, guys, thank you.